Rightio, so we're going to have a crack at working out some critical points. So we've got a function now which has got three variables, z, and is a function of x and y, and we're going to try and find out where the critical points of this function occur. And to do this we need to find the two partials and make them both equal to 0. So let's start off with the finding out the two partials. So partial z, partial x, differentiate this thing with x as the variable, so we end up with 5x to the power of 4. This one goes away because y is just a constant, minus 5, and that one goes away because that's y is just a constant again. And then the first partial with y as the variable, so x is a constant, so it disappears, so we've got 4y cubed disappears, minus 32. Okay, and we're trying to find where both of those things are equal to 0. So if we set partial z, partial x equal to 0, that implies that 5x minus 4 equals 0, which implies that x to the power of 4 must equal 1, so x equals plus or minus 1, or imaginary numbers if you want to go that far, but we'll just deal with the real numbers at this stage. And then we'll do the same thing with the y partial, so partial z, partial y has to equal 0, which means that 4y cubed minus 32 equals 0, which tells us that y cubed has to equal 8, which means that y has to equal 2. So our critical points, a bit of spelling drama there, points are at the points where x, y equals 1, 2, and negative 1, 2. Okay, so x has to be plus or minus 1, and y has to be equal to 2. Okay, and you could plug those numbers back into the original equation and work through to find the values of z at those points if you so wished, but that's where the critical points will occur.